Go. Yeah. So we are going to talk about AWS autoscaling. Autoscaling, we usually talk about EC2 instances. So an EC2 instance is basically is a computer that is remote, and you want to deploy your application on that EC2 instance. So that EC2 instance has resources, has the attributes, like for example the RAM, the memory, the hard disk, and then sometimes they get so much consumed. Even the CPU capacity gets so much used, and then that slows down your EC2. So there's something that is called the scaling. So when we talk about scaling, we talk about scaling in two ways. Scaling is where now you want to make sure that the application you are deploying is very much available, and the response time is meets the user expectations. Like for example, when so many, like you want to deploy an application that is being used by thousands or millions of users. So having them all run in one EC2 may not be feasible. Yeah. So we always talk about when the resources gets consumed, when the CPU is getting low, one server is doing a lot of things. Yeah, you might need to increase, yeah, either the CPU on that one EC2, or you want to increase the memory, like the RAM. Maybe you want to increase the hard disk as well. Personally, I have dealt with DigitalOcean, and I have met myself like adding memory, because the memory that is there cannot be done what cannot be is not serving the customer well. Yeah, that is, so when we talk about scalability, we talk about vertical scaling and horizontal scaling. So when we talk about vertical scaling, is what I've just described. You want to increase the resources of that one particular instance. That is the VM, that is the virtual machine. Yeah, the other scaling is where now you want to duplicate that instance. Now, which sounds a bit more feasible and good practice. So, now in AWS, when you want to have, for example, your application scale horizontally, you want to duplicate the server that you have, so that when the customer requests are too many, or they start rising, you want to maybe to reach at a point, for example, like maybe 80% of the workload. That at that point you want to duplicate, yeah, the traffic to another server. Yeah. So maybe I could draw a small drawing here before we go to this one. So assume you have one EC2 here, and you have a group of users. So these are users, and they continue increasing using one server. Yep. They are using one server here, and one server is serving them well, until now, when there will be too many, and the requests will be maybe when they are three. Yeah, this server is serving them well, but now when they increase, when they reach like numbers, they reach six, this server will maybe reach like 80%, 80% usage. Yeah, and that now it will start slowing down. Yeah. So with that, we have talked about, you either want to increase the resources of this computer. For example, you want to increase the hard disk. Maybe you're using like 60 gigs of memory. Yeah. Then maybe you're using like your CPU. You want to change maybe your CPU. Maybe you're using like a RAM of 2 GB of RAM, 2 GB of RAM. So when we talk about vertical scaling, you want to increase this one now maybe to 160. This one you want to increase to maybe like 8 GB. Yeah, that is what we call about vertical scaling. But basically, you want to increase the capacity so that this server can accommodate more users. Now, this is not good, yeah, because you will not keep going up, going up, going up on one server. And the other thing is, in most cases, actually, I've seen, like in, for example, in DigitalOcean, you don't have the what? For example, if you increase from 16 GB to maybe to 80 to 20 GB, they don't give you the option to scale down. So with that, we talk about horizontal scaling. Horizontal scaling is we maintain the same what? We maintain the same what? 60 GB of memory and maybe our 2 GB serving well for 3 users. Now we want to do this. We want to, when traffic hits, so for example, when traffic hit the workload, I mean, maybe like 80%, we could decide we want to now at this point we want to do auto scaling, and AWS offers that, and that's what we are going to look at today. So auto scaling is now we are going to duplicate this application from this server to another server, and maybe if the users still like they increase, yeah, we want to do the same, yeah. And then the good thing is now when the traffic again goes down, yeah, you can be able to delete the unused instances, so that you don't end up using what, yeah, paying for 3 servers, whereas the users are only 3. Yeah, so basically that is what auto scaling does. So first of all, I'm going to show you an example, and then we are going to I'm going to show you a working example. I think I like that approach of teaching, or of the, what do you call it, like doing a demo. I show you how it's working, and then we do the reverse now. How did we reach there? So I know we have not covered Terraform, but for the sake of so many things, we are going to introduce Terraform today, and we are going to Terraform is going to help us a lot with creating those resources. So here I have my account here. We have basically nothing. There's no resource that is running. Previously, we have been doing clicking of what? Clicking of links and creating manually. So, but today, I want us to take a step further and do the automation now. Do Terraform. Terraform is going to create for us the resources, and it's going to manage those resources. And you are going to see the advantage of that. Yeah, so the goal of today, let it not be Terraform. I've used Terraform for the sake of time. You see, within a 1 hour, it's not like possible to do all those clicks, but Terraform is going to make our work easier. So I have already a code here that is a code that I have written. Basically, if you can run through, it's not that much complicated, but one day we are going to talk about Terraform and AWS resources. So basically, this is going to create a what? This is basically going to define a region. We create a name. We create a what? We create a. Let me just do like appearance. Do it like presentation mode. Okay, so this is going to create a define the location. This is going to define the what? The VPC, then side range, and then this is going to create a subnet for that. Yeah, if you've been following, you know how like we have been dealing with subnets and placing them inside the what, inside the what, VPC. Then you are going to have another subnet here that is still public. We are going to provision an internet gateway. Later I'm going to I'll come in maybe in another tutorial or in another demo how we do all this in Terraform. So this is about route table. How now we are going to route the subnets through the internet gateway. Then the association, that is association, and then the security group, that is security group, and then after security group, we have other things here. We are going to talk about something that is called a launch template, and then we are going to give it a 20 GB of memory. Okay, I don't want to disturb your mind so much, because I don't want to introduce so many things, but basically this one is going to create resources for us. So let me run a command that will spin up the resources, and then as it is creating, so I'll say Terraform apply, then that is now going to start creating resources inside my AWS account. You see, it's going to do 15 resources, and currently it's saying that I have 0 to change, 0 to destroy, because my account is basically empty. So as you can see, let me try to zoom a bit. So it's creating the VPC, creating the subnets, creating the security groups. So let's leave Terraform to do that for us. It's going to take a second, or if not 2 minutes. And as it is doing that, let's go to this diagram that is here. So this diagram, I want us to, or rather, let that finish, then we will come to this diagram. I think it will make more sense, because if I talk about this diagram without doing a demo, that might not sit well. So let this finish. So we can draw an eye at AWS, see what is happening. So if you look here, we should have a VPC already created. I know the other resources are being created behind the scene. So already we have a VPC here. That is the side that we defined with our Terraform. And the route table has been connected. Okay, so and if we go now to subnets, they have been provisioned. We have defined 2 in our Terraform here. I think they are here. These are the subnets. We define them here. So as you can see, public subnet, Ec2, so that is exactly what we have here. The 2 of them. We have the internet gateway. One of the good things about Terraform is that Terraform is going to make your flow so easy. Personally, I've got myself forgetting to delete some resources. Like for example, when I provision a load balancer using the form, using the browser, I have there's a very high likelihood that I'll forget to delete that resource, maybe an internet gateway, a load balancer, and sometimes you might incur unnecessary costs because of forgetting. How does Terraform help you? Terraform helps you by, when you write this command, yeah, it's going to create those resources, and it's going to keep that a kind of a trail locally. Yeah, there are some things here that Terraform stores here, some states. It stores some states. So if you want to destroy all the resources again, yeah, you just say Terraform destroy, and then Terraform is going to remove all the resources, cascading. So what I mean cascading, I mean like for example, you go to AWS, you want to delete a load balancer, but that load balancer is actually being used somewhere by another EC2. So you need to go first and delete that EC2, yeah, before you come and delete the load balancer, yeah. But now with the Terraform, you just need that one command. That one command is going to cascade the request. So if you want to delete a load balancer, it will know, hey, you don't delete a load balancer before you remove an EC2. So Terraform is going to do that. So as you can see, I've created 15 resources here, and now if you go to our EC2, okay, into our dashboard here, we have all the resources configured now. The resources that I have basically is we have the VPC, we have subnets, we have 2 subnets, we have route tables, and then we have the internet gateway. From there, we have something that is called, let me go to the EC2 dashboard, EC2 dashboard, EC2 dashboard, and we have three EC2 instances that have been created. I think they are what? They have passed, they are good. And then those are other resources that I have. I have some that's called, we are going to talk about launch templates and see how that helps. And then we are also going to talk about load balancers. We have one load balancer here. And you're going to see the role of load balancer. We also have a target group. We're also going to talk about target groups. And then we have auto-scaling groups. Basically, that's all that you're going to do. So let me go back to our diagram now. Now that you have the resources running, yeah, we said that we want to have what? We want to have an EC2 here that is going to serve our customers. But this EC2 sometimes can scale horizontally. So when it's scaled horizontally, we don't know the IP address of each of these instances that are being created automatically by AWS. So for that, we provision a load balancer. So this code is going to be application load balancer, load balancer. So this is what happens. So this one is going to manage the traffics. So all the EC2 instances, they are going to report to the load balancer. Yeah, so the load balancer will do what? Let me just drag this one here. So that looks nice. Okay, okay, whatever. So the load balancer is going to distribute traffic. So the users now, they no longer access the one instance, because at any one time, this instance can go down. When traffic goes down, this one could be removed by the auto scaling group. So the users here, they are going now to access the load balancer. Load balancer is what is now facing the internet, or that is what facing the clients. So that is the work of the load balancer. Then we have something else that we call I want us to first of all to give that explanation. Then let's go back to our load balancer now here. So we have this load balancer. This load balancer is going to serve 3 instances. It's going to serve 3 servers. Yeah, and we have the DNS here. And what we have done, I have now this load balancer is going to serve these 3 instances. So our traffic is going to be distributed equally on these 3 instances. And you can define the number of instances that you want. You can define the maximum, the minimum. Yep. So let's access our load balancer and see how traffic will be changing from one EC2 to the other. If that was configured well, yes. So I have written a script to show me the IP address of one EC2. So for example, if we look at this one, 10, so this is at 10.0.2.37 IP. So let me see that. So our first request was served by, let me see, our first request, that was our first request. Let's see who served us. If I drag this one up here, come on Chrome, don't misbehave. So yeah, we have 10.0.2.37. That is the server that handled our first request. The next request now, if we refresh the browser, we were taken to another server, which is 167. Let's see if this is the second one. Yes, dot 167. So you can see how the load balancer is behaving. Then you can go to the other one. Yeah, now we were served by this guy. And that is how now the rotation goes. So there are many mechanisms of how you can configure your load balancer to work. like how do you want to channel your traffic? Yeah. So like for example, the first request will be served by this guy. This could be the first request, and then this could be the second request. This could be the second request. Yeah. As you have seen, I think it's following now this setup. Yep. So the first request, second request, third request, such that now your EC2 instances will not be so much overwhelmed. Yeah. So if these are some customers, if some customers are being served by this, maybe this EC2, some other customers somewhere, they are being served by this EC2 here. Yeah. So that is how, like, you see, we are accessing the same load balancer, but every request, yeah, every request is going to a different server. So that is how load balancing works. Yeah. And now we want to see about autoscaling. What is autoscaling now? Autoscaling is when we have, for example, there's somewhere we have defined in our okay, I don't want to go there first. Let me talk about this image first, because that will make things easier. So this is what we have. First of all, let me remove this one, because here was something I was trying to do that did not work. But let me join this one to a target group. Now let's talk about this diagram here. This diagram, we are coming from what? Let me come from the reverse. When we are creating an EC2, we always need a what? We always need to specify the size, T2 micro, T2 nano, T2 whatever, the size of that CPU. We need to define the key pair, like have you downloaded your private keys from the server? Then we need to define security groups. So what a launch template is basically, you want to define a template for your instances. So here we have 3 instances for now. On which template are they going to use? Because one common thing you realize about these instances, they are all the same. Yeah, they have the same number of RAM. They have the same number of memory. Everything, they are the same. The only thing they have is their like you see, their T2 micro, all of them, but they have been distributed in their different availability zones, but they have different IP addresses. So basically, for you to have these 3, like for example, if you want to launch a fourth instance, we must have a template from where they are going to be to define all this, the T2 micro. That is where we have something that is called a launch template. A launch template is nothing but instructions of, if you want to form another server, like the 4th server, where should we derive those templates, are those whatever. So let me show quickly where we do that launch template. So we have a launch template here, and this is now going to define the parameters over which our EC2 instances will be created. So if I come here, we are using the same AMI. So all the instances, they are going to be formed from this AMI. It's basically an Ubuntu based AMI. Then they are all going to be T2 micro. Yeah, they are all going to use this security group here. Availability zone. So in availability zone, you don't specify an availability zone, because you want AWS to manage that for you, but you give it options. For example, I can give you US East A, US East B. So are 2 availability zones. Yeah, place them accordingly, and AWS is going to manage that for you. So they are going to put some in one availability zone, other ones in another availability zone, for redundancy and for security purposes. And then they are all going to use this key. Yeah. So for example, if you were to create a launch template manually, maybe you would come here and you would create this launch template. You define the name of the template, do a description. Then the usual way how you want to define an EC2, you're going to be provided by this the AMI. You're going to select the instance type here. Okay, so this is the instance type. Then you're going to provide the key pair. You're going to provide the networking, storage, and basically now you're going to launch your template. But now that has been taken care of by our by Terraform. So you have that piece of code somewhere. If I just trash to launch template, yep. So launch template. Okay, launch template. Yeah, this is where we have launch template. This block of code now defines this block of code here. Let me do that until number from up to number 183. Yeah, so we have this block of code that is going to give a launch template. Yeah, and that is now the one that is going to give a template over which our instances. Now I drew this as a kind of an invisible kind of an EC2, because now all these they are going to copy from this guy. Yeah, so it's like a blueprint. A blueprint is a good word. This is a blueprint over which we are going to do create all these instances, and that is now how a launch template works. So a launch template sits there and it waits to be instructed. Hey, can you create for us another server? We are going to put from these attributes and create another server which is going to be placed in your auto-scaling group. Now let's talk about auto-scaling group. Let's go directly to AWS and we go to EC2 dashboard and we see what is an auto-scaling group and what it contains. So we are talking about this one. Auto-scaling group, basically, let me look at this. Yeah, so basically here is where you say the number of instances that you want. So for example, if your application workload increases, for example, as you start, you'd say the desired is 3, the minimum is 3, but the maximum, if anything, like for example, the workload increases, please do an extra one. Yeah. So you take care of these by where is that auto-scaling group? The auto-scaling group part should be here, this part here. Now this part creates the auto-scaling group. An auto-scaling group, we are saying that we want what? Let me not. I don't think it's here. This is called target group. Actually, let me go to auto-scaling group. It's here. This is auto-scaling group here. Yeah, an auto-scaling group. Basically, you're going to define the maximum, the desired capacity. For example, if we say the desired capacity is 4, if we say 4, and then the maximum is 4, minimum, so you can do the mathematics here. So the number of servers that you need. Yeah. So you can't say like the minimum is 3. This is going to conflict, and actually Terraform is going to throw an error. So if you say the desired is 4, the maximum maybe could be 4, and then the minimum size could be 4. So if, for example, I want to do, let me do 5 here, and I want to update this one. The good thing about Terraform, it's basically going to scale my instances. Now it's going to take them to 5. Yeah, so we are going to see now the launch template being called by auto-scaling group, and now we are going to have an extra server here. Yeah, we are going to see this now. We are going to see we are now going to have increased now to 2 more. So if I update this one, the first time Terraform maybe takes time because it's creating so many resources, but this time it's just going to refresh. It keeps a state of the current state that you have, and basically it's just going to do what? to update the what? I think we have a problem here. The desired must be between 5, minimum 5. Yep. I think desired 5 must be between 5. Okay. Let me do 5 everything. This is the what? Maximum 5. I just don't want to issues to do with logic. I just want to narrow down to the resources. So that's the error I was actually talking about. So it's going to add that one resource. So it's changing one thing. That is one change. And the change is going to happen in what? In auto-scaling group. So as that is happening now, I think we should be having another server. Now we should see another server showing up. It's either, now we have 3, now we should have other 2 coming up. If we remove this filter here, yeah, we have, okay, we have, I don't mind about the terminated ones, but we have another one that is pending now. Now this is coming up. This is now this is coming up. We have that one. I think this one is running. Yep. As that is happening, as we wait for them to do that, now we are now talking about the auto-scaling group. Auto-scaling group, basically, you are going to define how do you want to scale. Yep. So basically, you give the maximum size, the minimum size. We have something that is called the health check grace period. I don't want to check too much into that. And then, okay, this is a launch template. And then, exactly, now we want to attach our what? Our, what do you call it? Our auto-scaling group to a template, because now we are passing these instructions now to the launch template. So that is why we have to connect them here. We have to connect them here, the launch template. So we are going to give them, we are going to, hey, the launch template. These are the instructions. Add 2 more servers. Yep. So this now is going to take that, what? It's going to take that instruction and do what? Launch another 2 servers. So that is basically the what? The auto-scaling group. And then basically you connect it to your subnets. Yeah. So that maybe you have connected your subnets, so that, as in, if you are, let me show you what I want to say. You see, our instances, they are not all being deployed in one in one availability zone. Yeah. So maybe we have others in other subnets. So we have others in one subnet, others in another subnet. So that's why you have to provide the list of your subnets that you want to do what? To distribute your instances. And then basically that's all about not launch template, but auto-scaling group. So that is auto-scaling group. So auto-scaling group is just to pass the instructions down to the to the launch template. And if we look at that, let me now look at the resources, what is being created. What do we have now? We should have 5 instances running. 1, 2, 3, 4, 5. And now we have met our what? Now AWS is happy, like Terraform is happy that now the desired state is 5 and we have 5. And yes, now these 2 are initializing. They are not yet ready. They are not yet ready to receive traffic. This one has finished. So this one is not yet ready to receive traffic from the load balancer. So now load balancer, again, as I told you, when they connect, automatically they are going to register to the load balancer here. So if we have 2 more here, we have added 2 more. And the good thing, now we don't have to, the load balancer is going to do what? To automatically connect to them. And that is a good point, because we are now going to talk about target group. Yep. Auto-scaling groups, now they are placed in a in a kind of a containerization, not the Docker thing or containerization. I'm talking about grouping them, yep, in something that is called a target group. So that now the application load balancer can be able to, let me show you. Now the load balancer here can be able to do what? Let me do this. Put all of these in one section, and this is what we are going to call a target group. So a load balancer channels traffic to a target group. Yep. So basically, if now, okay, if we do this, now our load balancer is basically going to manage a target group, not like each individual EC2. So even if you increase the number of instances here, load balancer does not care. Yeah, as long as the target group does not change, the load balancer is going to channel traffic to the available instances. Yep. So okay, that is why we have this diagram here that is called a target group. A target group basically is going to say I'm targeting a group that is called a certain name, and then we have our load balancer here. Our load balancer is connecting to a target group. Our target group is now connected to autoscaling group, and our autoscaling group is now passing that information to the launch template, and the launch template now will do the hard work for you. So if we have a look at the instances now, they should all be ready. They should all be ready, the 5 of them, yeah. And now the load balancer now here have an extra 2 instances. So our traffic now can let me see that, yep, can now be able to use 5 EC2 instances, yep. Okay, so let me see that. So we have 5 there. I think this is the image that once we are able to understand this image, that we start from the launch template. A launch template has a blueprint of the EC2 instances that you want to deploy, or you want to have. The autoscaling group is basically going to define the desired state, like how many instances do you want? Do you want 3? Do you want 2? How much is your application? Yeah. So the intents of your application. So it's basically how you desire it to be. So for example, if your application has workload maybe on Mondays, Tuesdays, but maybe on weekends there's not that much traffic. Yeah. So the auto scaling group now, you are going to define the minimum that you can go down to. So for example, so that is about auto scaling group. Then auto scaling group is connected to the target group. The target group is now connected to the load balancer. So let me try to delete one EC2 here, and we will see it being replaced immediately, because let me try to delete this one, terminate this one, and when that starts being terminated, yeah, auto scaling group is going to realize that, hey, we need to have 5, but we have 4, yeah. And all those things are defined in the in the auto scaling group. There are some metrics that you check, how the interval of checking your servers, how many they are, their health. So for example, maybe this one is down, yeah. Auto scaling group is going to realize that and immediately replace with a new one. So for example, now we have removed this one. Now we are going to see auto scaling group now doing the hard work and then replacing our instance. So that one being terminated, we are going to see another one in a few seconds saying pending, because yeah, exactly, now we have another one that is being replaced, because the state is we must have a minimum of 5. Like this is a desired state, yeah, and AWS is going now to obey that, and you always have that the number of instances required. So right now, as we check now, this one should not be doing what, be having any traffic. And the good thing is our application is still accessible, yeah. There's nothing that has changed. Clients, they have never complained of any downtime. Yeah, so that is all about auto-scaling group in AWS. I know there are so many things that maybe time could not allow for me to go deep into into details. Yeah, but I wanted to give a bigger image of what is auto-scaling, and then maybe if maybe if even if we need more time, we can always come back to whatever to this and discuss more. Basically, I know we have introduced today we have introduced so many resources, and we have actually introduced Terraform. So the goal is not to understand Terraform, the goal is to understand the whole, like this is the picture that you need to understand how that works. Yeah, this is the bigger picture that you need to understand how it works, and that is all about auto scaling. And yeah, I want to leave a room for question, because I know these are quite maybe so many things that you have introduced. Yep. Anyone with a question?
Check on the chat.
Okay. Let me check that. So the resources that Terraform is creating are the ones you have had to create the room clicking. Yes, in the AWS portal. Yes, that is true. Yeah, the resources that they are being created here by what? By Terraform, they are basically the ones that we could, like, for example, not here. Basically the ones that you could come in here and want to launch an EC2 instance. For example, you'd come here and in AWS, okay, in EC2, you'd create a what? You'd create a launch an instance. Yeah, basically, the whole of this work now has been taken care of by Terraform. So if you understand how the resources are connected, and then you understand now the what the Terraform, how Terraform approaches AWS resources. For example, these are VPC, these are subnet, these are subnet. So these are keywords to AWS. So these are they are keywords to Terraform. So these are a subnet, you give it your value. Another subnet, you give it your value, and then you have internet gateway. These basically you get them from. Let me show you from Terraform by HashiCorp. Terraform AWS, like for example VPC. You can see that. You can follow that documentation here. But basically, we are going to talk about this again in another session. Yeah, because Terraform is we are not we are no longer going back to clicking things, because eventually we want to automate things as good as possible. Yeah, so these are VPC, you give it your value, and then region. So you have all these variables, and okay, yeah, variables that you need to assign out to. You are what you can call them test, whatever. So Erica, I believe I answered your question. So
Jeremy, that was a very good delivery of that content. I think it was easily understood.
yeah.
So I think I have a question with regards to number one.
Okay.
So basically, we have, let's say, for example, as a startup, I'm also thinking about my cost.
Okay.
I need to use technology in such a way that I'm cutting down costs. So basically, we have vertical scaling and also horizontal scaling.
Yeah.
So with aspect to costing, which one is better? And mind you, this application also, I have to factor in the type of application that I'm learning. I might have an application that is just a front end that is running on a different server,
Yeah.
but I also have a database running in a different server.
Yeah.
Meaning that also the delay could be coming on how my front-end application are consuming my APIs. So I'd like you to speak about the issue to do with the costing and how someone might look into that when you're looking to sell that to your boss.
Okay.
And then the second one is related to what we have done with regards to auto scaling. For me, it looked like it is a predictive policy that we are using, whereby we are predicting, or you as the owner of the application, you're predicting that I will have 5 servers will do okay. So I'm doing a predictive policy. So is there a way to do like a dynamic policy whereby I just need to write one policy and that policy, since it is dynamic, the system will determine, depending on what is happening or the traffic, it will deploy the necessary servers.
Okay, those are two good questions. I'll start with the first one. When you have a simple application, maybe it's serving maybe something a very basic application that does not need a lot of what, maybe a lot of resources. In regards to cost, you can make a decision. You can make a decision that you want to have only one server here serving your what. Like for example, now here we have 5. Maybe your application is very simple. Maybe just needs what? Just need one EC2. You could decide to maybe have one EC2 and maybe give the minimum capacity or the resource that you need. That is going to save you on cost and maybe in terms of what? In terms of configurations. The other thing is, I would think of it about like when you want to grow, because personally I was working in a company. I won't mention the name, but the configurations were not good actually. Like we used to manage how do you call it? We used to manage over 60 servers, for different clients. We used to manage over 60 servers for different clients, and those servers, you have to do what? You have to get into that application. To get that server, do the maintainability, the deploy the application there. You see, it's good when you have a small startup, but maybe when you think about it growing, that might not be good, might not sit well, because you might grow within 2 months, and then you realize, I don't want to interfere with my customers because one server is serving them well, and maybe duplicating that server because I did not automate that, it might be an issue. So you might get yourself having like over 1,000 servers, over 1,000 users on this one application. But if you had provisioned that, maybe the auto scaling policy, that could be you could give a threshold of, if my traffic gets to about 80% of this server, please duplicate to another one and serve them there. You see, when talk about cost, I see it like, because you see in auto scaling group, you can define you have these definitions here that you can say you want how many do you want. Let me see that auto scale. You have them. You have the minimum size and the maximum size. So for example, if you say like you have you see this you see this one, these are, for example, maybe you say you are a very small startup, you desire just one, and then you can say you have a maximum of 2, and then the minimum size, maybe you could say 2. if you deploy now this, yeah, for example, if your traffic now, this one can serve you, and this traffic is never going out. This auto scaling work is never going to be implemented until maybe you exhaust the capacity of this. Maybe, like, for example, you can give a threshold of 80%. Yeah, 80%. So you're always going to use one. Yeah. So my approach would be, have this set up here, set here the minimum. Maybe you have one. For example, now if I apply this one, auto scaling group is going to bring down all the other servers and remain with one. So only when traffic grows is we are going to get to 2, and you are never going to get to 2. The good thing about the auto scaling policy is you can define when do you want to have one again, when do you want to go back to one again. So if you come to a diagram here, yes, right now we have 5, yeah, but when there is no traffic, auto scaling group is going to delete all the other resources to save cost for you. Yeah. So auto scaling group, we are going to remain with one EC2, yeah, because there's no traffic. That does not for you. So we are talking about growing horizontally and scaling down again when there's no traffic. So that is the answer for the first question. The other question, you talked about the dynamics of how the policy of auto scaling. What I saw now, apart from these, are the desired. My thinking is, for example, if you realize there is maybe, I know there are other platforms of observing the workload in your instances, maybe without even coming to the EC2 dashboard or to the AWS dashboard. So for example, here you said you have maybe you need a minimum of 5. Desired is 5. Let's put as they were. So basically, you have defined here the number of instances that you want. When you apply when you apply this form now, this Terraform now, it's going to increase the ones that you have there, right? So, and then in auto scaling group, there is that policy of let me see. Okay. So the desired, there are some things I didn't actually touch, but there are some policies here. Health check, ELB. There are some policy. Okay. Behavior, replacement policy. Yeah, replacement behavior. Yep. This is something.
Okay.
Yeah. I didn't say this one actually, but that's a good question that I think I can check this one.
Yeah.
Customer behavior, terminated and launch, blah blah blah. I think there is quite a lot on this. Key maximum, minimum, 5 of all of instances. We have these ones. Yep. I think that's a question I can answer now once I do that practically, because I just wanted to keep this simple.
Yes.
Yep.
This was a good one. This was a good presentation. I loved it. I enjoyed it.
Okay. Thank you so much, guys.
If you can do some research on that,
Yeah.
I would love to know how the dynamic and like the one that the policy aspect to it, because that will mean there will be easier work in terms of managing those the instances, and the policy can take over.
Okay.
So yeah, maybe next time if you will be presenting on this, that would I would love to see what you find about the policy. Yeah.
Okay. Actually, next time we are going to do not to dig deep, into the whole thing. We are going to give it a second presentation so that you can see. Yeah. It's not actually that easy to comprehend all those things. We can now go one by one and make sure that we now this was a bigger picture presentation. But now next time we are going to get deeper into it. I want to show you the good thing about. First of all, I have this link here. With this presentation. I had done a GitHub. So I'm going to share this one in the group.
Please share.
I'm going to share this one so you can access the Terraform.
Yes.
You have the whole source code here. Then I want now to destroy. I want to show you how Terraform is going to do that for us. and now you just do destroy, then you just enter. Then so Terraform is going to bring down every resource gracefully. Yeah. When you say gracefully, like for example, even the cascading aspect, whereby maybe the internet gateway depends on routing table. Routing table depends on the association. Terraform is going to handle all that for you, and now you'll see everything. Like now, like this, now deleting the internet gateway, detaching them, auto scaling groups, removing them, and then now within a few minutes we are going now to have an empty the load balancer is going to go down. So for example, you just refresh before we finish, we could see that now the instances have come zero. The load balancer is gone.
Nice.
It's now working on maybe the auto scaling group. We are now you're also going to remove the subnets. You see, that's the beauty of automation, and that is why I prefer let us take the hard pill of understanding automation, because that is where we are going in production with, because we never go to production with clicking buttons.
True.
Yeah.
That's true.
Yeah.
That's true.
Okay, so I think I believe we have passed by 7 minutes, but I won't take much time for you. This one is going to delete behind the scene. So guys, that is it. Thank you for showing up, and then thank you for consistency. So let's meet on Saturday, and then we'll keep discussing more. And yep.
Thanks, Jeremy. Much appreciated.
Thank you so much, Henry. Goodbye. Good night.
Goodbye.